I think that,
Did you think better of it?
yeah, well,
So it's this guy down here. Everything's going to be in terms of y now. Remember, in terms of y means solved for x. So this is b and t is like bottom and top. Those are y values because it's a low and a high. Still doing big radius squared minus small radius squared, but now it's right minus left. It's on the top minus bottom. I think some of you wrote those down before, and some of you didn't. But I give people a chance to write that one down. I mean,
like, same with me.
I know what you mean. I don't know if the versus worth it,
I don't think it is.
but it's definitely not. I just didn't want to call you a company. Like, yeah, this guy was like.
Then I might start believing.
That's another way I've seen the formula written. So I've been using like all different terms, like outside, inside, big radius, small radius, furthest away from the axis, closest to. I've seen people do this, so this kind of clues them into like, okay, this is the bigger radius because it's capital letters. This is the smaller radius because it's small letters. So that works too. So, same exact idea. We're just turning everything sideways. So now we're going to go like I'm doing like this way. So our limits, our boundaries are going to be the lower and the upper y value of our shape. That's 0 and 1. And then this guy is x equals the square root of y minus 1. That looks like I'm pointing at the axis, but I'm not. I'm pointing at that. And then, so I've got like, that's my y equals 1, that's my boundary. I've got a boundary here. I've got this equation. I know this is so small, it's hard to tell. But that, I haven't done anything there yet. What's that equation? X equals -1, because that's a vertical line at -1. And we are revolving around -1. So this is one of those where we're flush up against, we're rotating around. So this is like your disk method, if you think about it that way. So what's going to go in that slot is just 0. We're subtracting 0. It's actually 1 minus 1. -1 minus -1 if you want to think about it that way. That's supposed to be a -1, but the negative and the equal sign join together. Okay. So then what I have to do is, so it's basically which, you got this equation here and this equation here. Which one's farther away from where you're rotating around? Is this one, and how far is it? Is right minus left, so it's this minus 1. Minus -1. So the square root of y minus 1 minus -1, because that is that sideways distance there, the right hand minus the left hand. Then if I said which equation's closer to what you're rotating around, you hopefully would say -1, and then I would say how far is -1 from -1, and you would hopefully say 0. So this just essentially becomes 0, because there's not that inner hole. It's just flush up against it. And that's your setup, you don't have to calculate it. Yeah. Questions on that? It feels like pretty similar, yeah? Just you gotta, but it's, most people aren't used to working with in terms of y, so that gets a little tougher for some. But before I go to the next one, questions on one there? I don't know if I'll do 2. I'm gonna find another one I think is. Yeah, I'm not gonna do 2. Let's do 3. No, stop. You'd still have to find the intersection points, so you would set these two equations equal to each other, like root y plus 4 equals y over 2 plus 4, and you'd have to solve that. I do have a graph, so I could just look at the lower y value is 0 and the upper y value is 4. Again, if you don't have a graph, you might not know which one's on the right and the left. So we would pick a number and plug in. So I'm going to pick a y value somewhere between 0 and 4, because that's our window. And I'm going to pretend I don't have a graph. So let's say I plug in let's say I plugged in 4. So the square root of 4, because I can take the square root of it fairly easily, that's why I picked that one. So that would be 6. But if I plug 4 into this guy, that's going to be 6 also, because that's where they meet on that spec.
I thought you were gonna show something really cool about it.
No, I was going to show you something stupid. Yeah. So the square root of 3 plus 4, I'm going to use 3 instead. And then 3 over 2 plus 4. Man, those are close. So you got to know, is the square root of 3 bigger or smaller than 1.5? It's bigger. So you'd have to know that, or you'd have a calculator. So this one is the one that's on the right. And when you got the graph, you can kind of tell because it's the curvy one. Or the other one's a line. So that's your x equals y over 2 plus 4. So then I got to do, okay, which one's, I'm rotating around the y-axis here. So which equation's farther away from my axis of rotation? Or what's my outside, or what's my big radius? It's going to be that guy, right? And how far is that guy from where we're rotating around? So right minus left is this minus 0, because this is just x equals 0. So this is the square root of y plus 4. If you want to write the minus 0 for like consistency, cool. If you don't, that's fine too. And then which equation's closer to where you're rotating around? It'll be this one. How far is it? It will be right minus left, which is y over 2 plus 4. Minus 0, but again, you don't have to write the minus 0. That's kind of optional. Give me like thumbs up, down, sideways, how you feel about this right now. Like it's not bad because it's the same as yesterday, right? Fair enough. Ish. Like, should I do more? Like, people actually answer me that time. It was a vehement shaking of the head no. Like, please don't talk anymore.
I got this.
Right. No.
I got it, right?
I listen though.